Alright, there's our DOM. I'm pretty sure we can all see that it's x squared plus 4, x squared minus 4. This easily factors down into x plus 2, x minus 2. The x squared plus 4 all comes down. That's pretty basic stuff, right? Yeah, pretty simple. So let's just keep going. We don't even need to spend 2 seconds on that. Anybody who does is an idiot. Okay. Our first set of problems. And if you notice somebody who's going to be watching this, you might soothe their soul by telling them that. Okay. Long division. Long division is the first thing we're going to be doing. Okay, here we go. Here's how you set up long division. Let's go ahead and just look at number 3. X plus 2 is our... I'm horrible with my vocabulary here. Let's see, if we had like 2 divided by x, x is the divisor. Yeah, if I had like just 2 divided by 1, 1 is the divisor, dividend, divisor, and this is the dividend. Dividend, divisor. Got it. I've been messing up my vocab all day. Yes, ma'am. Sure. Number 3. Oh, okay. Okay, sure. Yeah, I will. Yes, that is a very reasonable request. That's not dorky at all. Dorky would be like Spencer saying, number 87. No. That is a perfectly legitimate request. Oh, this is going to be a fun day today, I can tell already. Okay, number 3. So you set up your divisor and your dividend. Now, please pay attention because this one step is kind of the basis for the whole thing today, and yet it was still my most commonly asked question last block. The step on all of these long division is you take your first term of your dividend and you divide it by your first term of your divisor. X cubed divided by x is x squared. Now, long division works nicely if you keep everything in columns. All of my x squareds are going to go here, all of my x's are going to go here, and all of my numbers are going to go here. You want to space things out so it lines up nicely for you. Because x squared, x squared. That's why I was just talking about columns. So, we're going to take that x squared and multiply it back through. X squared times x, x cubed. X squared times 2, 2x squared. Now, important step coming. Please pay attention. This was positive, right? 2x squared. Put it in parentheses and put a minus. We're going to subtract that. So many people put the minus, but they don't put the parentheses. And then they do x cubed minus x cubed, 5x squared plus 2x squared. That minus distributes throughout the parentheses. So that's why it's important to put that. Yeah. What? Yes. X squared times x, x squared times 2. Yep. Yes, ma'am. Yes. Whenever you multiply whatever, because in a second we're going to have another one, then another one, then another one. But whenever you multiply back through, you always want to put everything that you got when you multiplied in parentheses and then subtract. That's always a step. I took x squared times x, x cubed. X squared times 2, 2x squared. And I'm going to subtract both of those. Yes. 4. Dos punto cuatro. X cubed divided by x. First term, first term. Boom. X cubed over x. Yes. Yes. Every single problem. First term divided by first term, that's how you kick them all off. Okay. Now we're going to subtract. X cubed minus x cubed. If you do this right, that should always be a 0. It should always be a 0 if you do that correctly. 5x squared minus 2x squared. That's right. See, if we had left off this minus, we would have added and got 7, which is wrong. All right. Now, at this step, we've essentially finished our first step, and you're going to do the same. What the heck? We're going to do the same exact thing again. 3x squared divided by x. First term, first term. And what is that? What is 3x squared divided by x? 3x. Positive 3x. Notice how I'm putting that over my x column. Now, just like in the last step, what do I do with that 3x? Multiply it by both pieces. 3x times 3x. 3x times 2. Just like here, put in parentheses and subtract. Now, at this point, what do we subtract from the 6x? This piece comes down. Okay. No problem. Bob. Yes. What? Yeah, I missed you. Big time. It's hard keeping him awake. What? Yes. Yes. I hear a whole lot of chatter, and I'm pretty sure most of it's math. But so, are there questions about something that's on the board? Do you have a question, or is that just an emotional concern? I'm sorry. Here we go. 3. Oh, did you have a question? Well, I've never tried to do that. Allie's apparently put them in words, so maybe she could give you those in a bit. Shh. Here, we'll take a pause, and I'll write these down up here. Okay. Actually, Allie, you just want to write them up here? Okay. Yes? No? Yeah, I'll bring it to you. All right, we're going to put this process into words. So pay attention. So, just keep going. First term of, make sure we're getting this in our notes. What? With this problem? First term of dividend divided by. Ooh. You got to watch the board. You can't watch that screen. You got to watch up here. Because you push the button. Term. There you go. We're having too much talking, guys. I know. Okay, step 2, kind of. There we go. Yeah. I've lived this pain. Multiply back through divisor very nicely. Step 3. Okay. This is for the first example. You might want to link that in your notes. Oh, you want me to? Good. Actually, you forgot to subtract first. No, I guess you could. I guess you could. Okay. Oh, I need you to move your pen. That pen works as a mouse. That's why. I could, yeah. Okay. You just hit the green arrow on that green box. No, on that green box. The right green arrow. There it is. Bang. Subtract. A smartboard? Let me tell you something. In my first 3 years of school, I used a smartboard more than any person in this state, probably. And they're like, let's move classrooms and take away his smartboard. I was a magician with that thing. And so many teachers use markers on their smartboard. They literally write on their smartboard with a marker. And I don't have one. Yeah, I'm better. But this will work. Anyway, thanks for talking about that. Basically from here, repeat until finished. Seriously, it's just the same step over and over and over again. It really is. Once you do that, whatever that says, you just repeat that until you're done. Thank you, Allie. Everybody need me to leave this on the board for a minute? So, let's discuss this real quick. You've got those written down, right? So, first term divisor divided by first term of dividend. Bang. That's where this came from. Then we took that in step 2. It was step 2, or step 3. Step 2. We multiplied that by x plus 2. Boom. Now, then you would subtract. You can bring down the 7x, although it would just kind of come straight down. But then you subtract. Whatever you're left with is basically your new divisor. And you're just doing the same exact thing again. And again and again and again until you can't divide anymore. So that's what got us here. Then we said, okay, first step all over again. 3x squared times our first step was 3x. Then we did our second step all over again. 3x times that binomial. 3x times x, 3x squared. 3x times 2, 6x. Then we did our third step all over again. Minus that quantity. Subtract. Again, you should always get 0 if you did it right. 7x minus 6x. Now what? We're going to do the fourth step all over again. And then we go repeat until finished. Back to the first step. X. Well, not yet. What's x divided by x? Uno. Then we do the second step all over again. 1 times x plus 2 is x plus 2. Third step all over again. And if there's nothing left, then there's no remainder, and this is your answer. Not always. We are happy when it becomes 0. Now you may be thinking, Mr. Crawford, you said this was going to take the place of factoring. How in the blue blazes does this have anything to do with what we've been doing? I'll show you. By dividing out x plus 2. It's like this. What is 12 divided by 3? Can't we also say that 12 equals 3 times 4? Same thing. X squared plus 3x plus 1 times x plus 2 equals our original. Really, by dividing it out, all we've done is factor x plus 2 out of this. And what's left actually is called, well, in this step it's called our quotient. But in a minute, when we look at this as more of factoring, this is called your depressed polynomial. That's the actual name for it. I think that's this one. A depressed polynomial is what's left after you factor out part of it. So this division is really nothing more than factoring. So if you hate to factor, this should be something you like. Well, it's going to get easier. It's going to get easier. All right. Let's look at a harder one. Good idea. Let's look at 13. And then we'll look at 15. And then I'm switching slides unless you have more questions. 13. All right. Our divisor. Dang it. Is it dividend? Quit it. You're shaking my confidence. Wow. It was going that poorly? It was going that poorly? I'm sorry. Okay, good. Yeah, that'd be really disheartening if somebody's like, and they just walked out. That'd be so funny, but I would write you up. Okay, for being a distraction. Here we go. First step. First term divided by first term. 6x cubed over 3x squared, 2x. Notice I'm lining them up, x over x. Second step. Take that, multiply it through by your divisor. Divisor. 6x cubed is 2x times 3x squared. 2x times negative x is negative 2x squared. 2x times negative 3 is negative 6x. That's all I've done is multiply it back through. Third step. Put it in parentheses and subtract. Bless you. If you did it right, what should your first one always go to? 6x cubed minus 6x cubed? Yay. 13x squared minus a negative 2x squared makes it plus, so this is 15x squared. 11x, negative 11x plus 6x, it's negative 11 plus 6, so it'll be negative 5. I'll stop there and let everybody get caught up. Okay. Repeat the process. First term divided by first term. What's 15x squared over 3x squared? 5. That goes up here. And we multiply through again. 5 times 3x squared. 15x squared. 5 times negative x. Negative 5x. 5 times negative 3. Negative 15. Now I guess I can go ahead and bring this down. Subtract. Oh, look at this. Happy face. Happy face. Happy face. They're all zeros, which means you have no remainder, and this is your solution. 2x plus 5 is your finished answer. Minus negative turns it into plus. That's why it's important to put those parentheses around before you minus it so that you remember to distribute. Okay. Questions on that one? We're only doing one slide of long division, so some of y'all are really hating this, and maybe that can be a comfort to you. Has everybody got this written down? We're going to look at one more. Yes, I will. No. No one's favorite part of math is long division. The questions, Tyler. Okay. Here we go. 3x squared plus 1. Now, this is an important step that I'm about to show you. Any missing term... I haven't even written anything. Are you writing the original, or are you trying to write out the first step? Because, okay, because I was going to say you can't write the first step without my explanation. That's why I haven't written it yet. But okay. When you divide polynomials. Any missing terms you have to fill in with a 0. Now, we're going to take a step back from this problem for a second for me to show you an example of that. Let's say we had, this is just a different example. Let's say we had, I'm just going to make one up, 6x to the 5th plus 1 divided by x minus 2. When I write that out, I would have to do x minus 2 divided by 6x to the 5th plus 0x to the 4th plus 0x third plus 0x squared plus 0x plus 1. The reason that's important is because just because those terms are missing now, if we were to start working this problem, when you divide, you'd actually have a 4th and a 3rd and a 2nd when you started subtracting. And if you left those out, you'd have nowhere to write it up here. So you need to keep, anytime you have a missing term, you need to fill in with a 0. Now how does that apply to number 15? That's right. Yeah, missing an x and a number. So that's going to be 18x to the 4th, 9x to the 3rd, 3x squared, 0x, and 0. Sure. No, that one you don't have to write in. That one you don't. Good question. Okay. Yes, sir. Sure, she's wonderful. Thank you for asking. Okay. Here we go. 18x to the 4th divided by 3x squared. 6x squared. Notice I wrote it over the squares. 18x to the 4th divided by 3x squared is 6x squared. Step 1. What is step 2? Multiply. 6x squared times 3x squared is 18x to the 4th. 6x squared times 1. Notice how I'm skipping the cube term because we're not going to cover that one right now. It's 6x squared. And then I still do my minus thing. I'll give you a moment to copy that down. Because there was nothing that I multiplied this by that gave me a cube. And I want things to line up. 4ths, cubes, seconds, x. But if you want, we can fill this in with 0x cubed if that's going to help you visualize it. Okay, here we go. We're going to subtract. What is 18x to the 4th minus 18x to the 4th? Happy face. 9x cubed minus 0x cubed. 9x cubed. 3x squared minus 6x squared. And we're ready to repeat the process. It is exciting. Alright. 9x cubed divided by 3x squared. Very good. Multiply it back through. 9x cubed and 3x. If you want to add the 0, that's probably a good step to take. Just write in a 0 for any terms that are missing. This one? 3x times 3x squared. There are also examples in your book with lots of arrows and things like that, so feel free to look at those too for extra guidance. Here we go. 9x cubed minus 9x cubed is a happy face. Negative 3x squared minus 0x squared is still negative 3x squared. 0 minus 3x is minus 3x. And repeat the process. Negative 3x squared divided by 3x squared. Negative 1. What's my next step? Multiply. Negative 1 times my original is negative 3x squared minus 1. I'll go ahead and add in the 0x for good measure. And we're ready to subtract. Very good. Bang. Here we go. Subtracting. Negative 3 plus 3 is happy face. Negative 3x plus 0 is negative 3x. 0 minus a negative 1 is plus 1. You're right. You may notice at this point you can no longer divide this by this because this 3x squared is bigger than negative 3x, which is your cue that this is now your remainder. Whenever what you're dividing by is smaller than what you're dividing, then it's your remainder. And here's how you write your remainder. Always use a plus sign. Plus your remainder over your original divisor. Or dividends, or whatever it is. Not a space. I don't think I can leave everything on here. Your remainder divided by your original dividing thingy. Questions? That's the hardest thing you're going to have to do today. Did you just do the John Wall dance? Pretty sure that's... Okay. Alright, checking. Right here. You're right. You're right. When we took this and multiplied it, we got these two things, right? And we had a gap here. And Kyler correctly pointed out, what do we do with that gap? And I said, well, it's going to... Essentially, this piece is just going to come down, but that might be easier to visualize if we just, for missing terms, plug in a 0. That way, it's like 9 minus 0, and it makes it a little clearer how this just drops down. Any missing terms, you plug in zeros for. Because it won't line up otherwise. Otherwise, if we had stopped, alright, if we had stopped right here, oh, dang it. Then I wouldn't have really been able to visualize where to put the 3x, where to put the negative 1. It doesn't line up as well. So any missing terms, you need to put in zeros for. Alright? Questions? Okay, now, if you are so fortunate to have to divide, like on number 1 and 3, see how it's just a binomial, x plus or minus a number? Just x plus or minus a number. If you have some like that, then you can divide them using synthetic division. Please notice all of these are just x plus or minus a number. Synthetic division, if you look away and then look back and see the work, you're going to think, what in the purple Francis did he just do? But if you pay attention, it's the easiest thing in the world. Let's look at number 17. To use synthetic division, you'll always be dividing by x minus some number. Or the easier way to think of it is, remember how like for horizontal shifts or roots or zeros, we said what's going to make those equal to 0? What's going to make those equal to 0? 2. So, you're going to put that number in a little box up here in a corner. 2. Whatever's going to make what you're dividing by equal to 0 goes in the corner. Then right next to it you write the coefficients from your original function. This is number 17, by the way. 2, 1, negative 10. 2, 1, negative 10. Draw yourself a little line. Now, hold on. You always drop down your first term. It just comes straight down. Anything that's below that line, you're going to multiply by what's in the box. 2 times 2, and you write it here. 2 times 2, what's 4? It goes there. Anything above that line, you add with whatever it's lined up with. So 1 plus 4 5. It's below the line, so we multiply it by the box number. 2 times 5. Add in your column. Your last number will always be your remainder. Always. Now, let me ask you this. If I had like 7x to the 6th divided by x, what would my answer be? Yes, you do. Yeah, you just reduce it by 1, right? Since all of these are dividing by just 1x, then your answer will always reduce 1 power of x from where you started. So since we started with a square, reduce that by 1, and this is just going to be x plus 5. 2x plus 5 is your answer. Yes, sir. Yeah, you just add anything in that column. Negative 10 plus 10. You don't have to dull yourself. So, again, what have you just done? By dividing, you have factored number 17 into x minus 2 times 2x plus 5. You've just factored that by dividing. And that would have been a tough factor otherwise. It's going to be whatever you're dividing by, your dividend, one of those. Whatever you're dividing by, whatever makes that 0 goes in the box. So, for instance, on number 23, what's going to go in the box? 2. Another way to remember it, please stop using the markers. If you minus, it'll be positive. If you plus, it'll be negative. Okay, 2. Yes. 23. Yes. Where did I get this? I multiplied. 2 times 2, 4. Added. 2 times 5, 10. All right, so after we put the 2 in there, does anybody remember what goes on the top row? The coefficients. I'm going to stop you right there for a second. Are we missing a term? Which one? Yes. Yes. No. It's not a it's just whatever makes this 0 goes here. Okay. Now, if there's any missing terms, just like long division, you have to plug in a 0. So that was 6x to the 5th, 0x to the 4th, negative 2x cubed, 4x squared, negative 3x, and 1. Sorry. I'm sorry. Yes, it is. Okay. What drops down every time? The first term. I think so. If I can get this out of my system. Multiply. 2 times 6. 12. Stop. Then you add 0 plus 12. 12. Multiply. 2 times 12. Add. Then you multiply. Where'd my student participation go? Well, it's a fickle thing because some people want to write and some people want to go, and I'm trying to please all parties by going in a medium speed. 48. 92. And the last number is always your remainder. Now, what power is my quotient, my whatever I'm left with, what power is that going to start with? 4, because we started with a 5th and you lower it by 1 every time. So that's 6x to the 4th, plus 12x to the third plus 22x squared plus 48x plus 93. And just like when we did long division, your remainder goes on top and your original divisor goes on bottom. I'm dying up here, people. I need a weekend. No, I won't go to the hospital as long as there's something to be taught. Have you now? Okay. Please raise your hand if you have a question about anything we have done thus far. No. You may never ask that question again. I've already talked about that question. No. Are there any questions about this process? They're all going to be the same. Yes. 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 Factoring. Yes, absolutely. Yeah, I was just meaning it was kind of a sweeten the deal kind of thing. If someone hates the factor, yeah, you're going to have to use this stuff sometimes. And in fact, today you will. Okay, now, we're not going to work anymore since nobody had a question, but I will say this. 29. This is how 29 would set up. Just make sure you understand the leaving a blanks principle. That would be 4 up here in the box. Dang it, we didn't do a single one with a negative. Oh well. That would be 1x to the fourth, 0x cubed, 0x squared, 0x, negative 256. That's how that one would set up. We don't even have to... No, you just have to multiply by a negative number every time. What? What do you mean? Because you can only do this when it's just x and a number. See, some of these were like full like trinomials and stuff. You can only use synthetic when it's just x and a number.
So whenever it's negative, it's positive. Whenever it's positive, it's negative.
Yes. Yes. Questions? If I were allowing you to use that. I don't even know how you do that, actually. You know how to divide polynomials in the calculator? On a TI-83 or a what? Huh, I'd be interested to see that. If you had a nice teacher who let you use a calculator, yes you could. Alright. Next. Now, we're going to use synthetic division of the remainder theorem to find the indicated function value. Now, if I asked you for f of 4, what would you just naturally do? Plug it in. You can do that here too. I'm not going to make you do it the other way. But here's the thing. What they're trying to get you to notice is, Allie, if you're pretty good with the calculator, I'm going to let you actually do this. I want you to take 23 here. I want you to plug 2 into this function and tell me what it equals. Plug 2 into that original function and tell me what it equals. Actually, I may have already done this. That is what you should have gotten. I think it's on my calculator too. Yes, it is. If you plug 2 into this function, sorry, I didn't mean to cut you off, you get 187, which is the same thing as your remainder. The remainder theorem simply states if you divide a binomial by a polynomial, whatever the remainder is would be the same thing as if you put the root generated by that binomial, so this one would be 2, negative 5, negative 5, positive 2, positive 1, would be the same thing as if you just plugged that into the function. So, all this slide wants you to do is do synthetic division, find the remainder, and just acknowledge that that number would be the same thing as if you just punched in a value. Of course, I don't care if you just want to punch in the value, since you know that they're the same, but it's just important to know that they will be the same. Questions on that? Louder?
What is this?
They just have it on their remainder.
Yes. Sure, sure. I'll do 39. It has a fraction. Nobody likes fractions. I'll do 30. Oh, go to the last one? Yeah. You got it? Okay. Okay. All right. So, you are more than welcome to just punch these in like we've been doing all year, like an XY chart or something. But here's what you'd get. In fact, Matt, why don't you plug in -1/2 into that function, and then don't tell me what it is, and we'll see if we get the same thing. I am going to take this out. Now, I don't have to flip the sign. If it had told me x plus 1/2, I'd have to flip the sign, but it just told me what to punch in, so I don't. So that's 2, -5, -1, 3, and 2. Now, because we've already practiced synthetic division, I'm going to kind of sprint through this. I'm not going to wait for every single step, just because I'm really just showing you that it works. 2, -1, -6, 3, 2, -1, 2, -1, 1. Matt, or yeah, whenever you get done. Oh, darn. It's a race. Somebody punch in -1/2 into this function, and please tell me you get 1.
I got one.
Yay!
Yeah.
There you go. That's the whole point of this slide. Just to show you that if you were to divide it out synthetically, you get the same thing as if you just plugged it in. Whole point. I think it's easier to divide it out synthetically. What? Yes. The remainder is the only thing you have to punch it in. I mean, it's the only thing you have to list. Now, again, if we can just punch it in, what's the point? Back to the factoring thing I told you earlier. Here's where all this is going. This is the last slide. Last slide. Here's a polynomial. Today, they're going to give you one of the factors. They're going to give you one of the factors, which I will not be doing in the next few days when we come back. I'll be showing you how to find it. But, so for 43, there's a factor. It says, use that factor to find all the zeros. How many zeros is this function going to have? 3. Watch what happens. We're going to divide this out using synthetic division. So what am I actually going to divide by? What's going to go in the box? -1, right. So that's 1, -4, 1, 6. Again, this part we've already practiced, so I'm going to kind of sprint through it. It'll be 1, -1, -5, 5, 6, -6. Hurrah, 0. If something is a factor, now think about this for a second. Turn those wheels. If this is the same thing as if you punch it into the function, then that shows you right there that x plus 1 is a factor and that -1 is a root because its y value is 0. If you ever get something other than 0, you've either done it wrong or that's not a root of the function. Yes. No, it's -1 because it's x plus 1. It's always what makes that 0. Okay. Now, what is my depressed polynomial here? Thank you. X squared minus 5x plus 6. How can I find those last two zeros? Quite simply. It's a big Q word. You could factor. What's another way you could do it? The quadratic. -b plus or minus b squared minus 4ac all over 2a. All I did was punch in 1, 5, -5, and 6 into the quadratic equation. That's going to be 5 plus or minus the square root of 25 minus 24 is 1 all over 2. What's 5 plus 1 divided by 2? What's 5 minus 1 divided by 2? 2. And my third one, I've already found, was -1. Bang. you just found all three x-intercepts or zeros for that function. You divided it out synthetically, took your depressed polynomial, used the quadratic, bang, you have all three of your roots, and now you could graph it if I asked you to. That's the point of all this. 43, 44, and 45 are going to work the exact same way, except we don't have to flip the sign because they didn't give us a factor. They just went ahead and gave you the actual number itself, the actual root. So you can just plug that number straight in without having to flip the sign. That's all you have to do. Yes. That's all you have to do on that one too. Find the zero. Divide one of them out, use quadratic. I think most of the rest of the questions I should probably just answer one-on-one, so I'm going to go ahead and cut you loose. You know, I've never heard that. No one in my whole career has told me I teach slowly.